All right, the activity that you're about to begin is called Measure the Galaxy, where we're actually going to look at how to physically take something here on Earth and try to make sense of how large the galaxy actually is. Because, you and I are very much alike in the fact that the galaxy we know to be extremely large, but really we're going to start off with the lab itself and kind of give you a perspective. We're going to try to imagine and try to put into some context that the 13.7 billion years that the galaxy has existed, how far does light travel? In order for us to understand exactly how old the galaxy truly is. And when we look at how far light travels at 5.8 trillion miles, to comprehend exactly how far that is and then multiply that by 13.7 billion, it becomes extremely huge. I mean, numbers that you and I will never understand except we look at a piece of paper and say, wow, that's a big number. So what you're going to do is your task is to either A, do this lab by yourself, which is perfectly fine, or B, you want to gather up at least two more individuals so you have a group of three. And if you have a group of three, we'll talk about the jobs in a moment. The material engineer, experimental engineer, and then the data processing technician will be the three tasks your group will have. If you don't want to work in a group, that's perfectly fine. You're more than welcome to do all three tasks by yourself, no problem. Okay, once you've decided, you'll gather the lab materials for this lab and you'll go ahead and get started. The lab materials are located up here. You're going to need about a tablespoon of uncooked rice. You'll get a meter stick, calculator, 15 meters of string, and glue stick. Along with that, it's not listed here, but I did include it, and you'll see it on your copy. I also included 2 sheets of 18-inch by 11-inch paper. So you have some big sheets of white paper, and I'll explain to you why you're going to be using those in a minute. Okay? So you'll start by simply just reading this general thing about, trying to imagine what distances are and what it would be like to travel. Second is, if you are working in groups, here are your tasks, and these are the responsibilities for each of the people within your group. Okay, the materials engineer, experimental specialist, and the data processing technician. Okay, so let's go ahead and get started with here's what you're going to do. Okay, so for the first procedure step, part 1, what you're going to do is you're going to be looking at one simple grain of rice. And again, 1 grain of rice is going to be equivalent to Earth, which is 13,000 kilometers in diameter. That's what 1 grain of rice is going to be equal to. So for every single grain of rice, it's going to equal 13,000 kilometers. Okay, so if you had rice next to each other, you have 2 of them, it'd be 13,000 plus 13,000. Have 3 of them, 13,000 plus 13,000 plus 13,000. 4 of them, 5, 6, how many it is. So again, 1 grain of rice is equivalent to 13,000 kilometers. Okay. What you'll then do is you're going to try to calculate how many grains of rice it would take for us to go from Earth to the moon. And once you've got that, you will then write that information in the student data table, which you will find over here. You'll put in grains of rice, how many does it take to get to the moon, and then the length of rice grains, we'll talk about what that is in a moment. Okay, so then next, using this information, you're going to come up with a mathematic plan to change the distance from Earth to the moon using grains of rice laid in a row. So what you're doing is you're creating a scale. 13,000 kilometers is equal to 1 grain of rice. So how many grains of rice does it take for you to get to the moon, to a planet, to a star, whatever it may be? What I'd like for you to do is I want you to write this plan down. You're going to need a separate sheet of paper. Lined piece of paper would work fine, or a computer paper, that would work as well. And I want you to come up with your reason as to how you're going to perform this experiment, how you're going to create a mathematic plan to do the measurement. So how are you going to figure out what's going to be your plan of attack for 1 grain of rice equals this much, and how are you going to then figure out how 1 grain of rice is then equal to X amount of miles, kilometers, distances. So you're going to come up with the idea about how you're going to create a scale. 1 grain of rice equals how many kilometers? 2 grains of rice equal how many kilometers? So you come up with whatever scale is going to work for you, and then once you have a plan, I want you to come find myself or come find Mr. Fusak and show us your plan. And then once you've got your plan, I want you to compute the, using your scale, compute the distance to Earth, and then write that number in your data table, which is right here. This would be the length of rice grains occupy, and you'll write that right here. Okay, once you've done that piece, you're going to take that 18.5 by, or 18 by 11, and you're going to draw a line that is going to, you're going to basically place the grains of rice on so that you can see how far this is. Okay, so what you'll do is you'll draw a line on your piece of paper that you've got, big white piece of paper, and you're going to draw from corner to corner, one straight line, so you can use your big meter stick that you have. Once you've done that, you're going to lay the grains of rice next to each other to stretch them out, to give you an idea about how big the scale is until you reach the actual moon. So you've already done the calculation about how many pieces of rice you will need to do that. So count them out and then put them on your piece of paper. If you want to lay them without using the glue, you're more than welcome to, or put a strip of glue down and then lay them so they don't keep moving all over the place. But I just want to give you a perspective as to what it looks like when we talk about scales. Okay, after you've done that, you're going to use the same calculation that you came up with to compute now. You're going to actually do some more math. The number of rice grains needed to measure the distance to other planet. So if you go back here to your data table, you notice that the planet that we're looking at, we've got Mars, we've got Pluto as our planet. So now what I'd like you to do is I want you to figure out how many rice grains it would take for us to get from the Earth to the Mars and then also to Pluto. Once you've got that, you're going to write the number down in your student data table, and then I'm going to ask you some simple questions about would you like to count these and why or why not. Alright? Then procedure step number 4. This is where it's going to challenge you a little bit, because instead of using rice grains to measure distances, I'm going to ask you to start to think about something other than rice grains that we can use, turning it into a distance to measure these very large galaxy distances and universe distances. So what you're going to be asked to do is you're going to look at the millimeter side of your ruler, and then you're going to be asked to draw a scale on a piece of paper. Alright? Once you've completed that, you're going to use a new plan. Now, instead of using rice grains, how are you going to measure 1 millimeter is equal to how far? What is that distance going to represent? And then you're going to write your plan down. So again, you're creating a formula, something you can use to measure the distances out in our universe. Instead of using rice grains, we're going to then move on to something else, such as millimeters, so that we can make a scale within our classroom. Okay? So you'll be answering a few questions along the way, and then it'll give you a perspective about how far these things are. Again, remember, make sure that you are doing your calculations, make sure that you're writing down your data, and make sure that you're consulting both with myself and Mr. Fusak along the way, especially if you have questions about how to calculate and maybe the math plan that you're trying to create for the distances itself. Okay?